Okay, so let's do practice quiz 7, number 1. It says let R be the region bounded by x greater than 0, y equals x plus 2, and y equals x squared. Find the double integral over the region x squared y dx dy. So let's first graph the region we're talking about. This time it's not going to be a rectangle. So it's saying x is greater than 0, and it's a parabola. So let me do a graph here. So say here's 2. So at 0, this line is at 2, so it's going to go like this, this line. And it's a parabola, so we're looking at the right half of it, so it's going to go like this. And it's going to come across here. You can check that this point over here should be 4. And the point below, so if you check when x is 2, that's 4, and that's also 4. So that's where they intersect, these two things. That'd be 2 down here. So we have to find the area, the volume of the surface over this region. So there's a region R. So we're doing dx dy. So let's do a strip. So we're doing x first, that means y is fixed. So let's do a little strip here. So here, that point right there, you call 0y, and the point over here then, we can call xy. So you can think of, so above this strip there's a surface. So let's say that's what the surface looks like above the strip. So I'll be finding, when I integrate along the strip here, I'm finding the area underneath this guy, and with some thickness. So it's like a slice here. And as you go, you got different slices, and you're going to add them all up. That's the idea. I'm not going to try and graph this. We don't need to answer the question. So, okay, so we need to write, so the y is going to move along the y-axis here from 0 to 4. We need to write x as a function of y. So note here, this y is on the parabola over here, so we'll have then y equals x squared, and x is greater than or equal to 0 from this condition up here. So then taking square root on both sides, we'll have y equals square root of x. Oh, sorry. Messed up there. I mean x equals square root of y. So in particular then, if I drop down here, that would be square root of y. That's my x value. Okay, so then over here, this is going to be double integral. So it's going to be from 0. So the x goes from 0 to square root of y. That would be x squared y dx dy, and the y can go from 0 up to 4. Never mind. It'll be 0 to 2. I'll explain. 0 to 2, because from 0 to 2 it goes from the y-axis to the parabola all the way up. But when you pass 2, it's going to go from, I draw another strip up here. Oops. So drawing a strip up here. So from there it's going to go from the line to the parabola. So this point up here, let's call it, say, x1y. And this guy over here would be x2. Now it has a different x value, but it has the same y value as this point over here, so it'd be y. And then note, so this guy's on the line's giving up here, so it would have then y equals x1 plus 2. So now we can solve for x1, so x1 would be then, subtracting 2 on both sides, y minus 2. And here, and so Again, this guy's on the parabola. The parabola is given by this, so you'd have then y equals x2 squared. So then x2 would be square root of y. So this then would be plus double integral from, so now 0, sorry, not 0, from your x1 here is y minus 2, up to x2, so it'll be square root of y. And the y goes from 2 to 4, so it'll be 2 to 4 x squared y dx dy. Okay, so it's going to require two integrals to figure this out. So again, just to recap, we're taking slices, the surfaces above, and we're adding up all slices to find the volume. If we had to do dy dx, which we'll do next, we'll be doing slices this way. We'll do that one next. But right now we're doing dx dy, that means slices this way. That means slices parallel to the x-axis. Okay, so let's keep going. Okay, so let's start integrating these guys. So first one is integral with respect to x. So it'll be 0 to 2. So integrating this guy with respect to x would be x cubed y over 3. Then evaluate it at 0 and square root of y. We still have our dy. And then next one, plus integral 2 to 4. So it'll be also x cubed y over 3. This time we evaluate it at y minus 2 and square root of y dy. Okay. Now we're going to put the square root of y in place of x, and then put 0 in place of x, square root of y in place of x, minus y minus 2 in place of x here. So doing that, the first one from 0 to 2, so putting, so you can write that as y to the 1/2, so it'll be y to the 1/2 cubed times y over 3 dy for that one, and then plus integral 2 to 4. So same thing here, it'll be y to the 1/2 cubed y over 3, and then minus y minus 2 cubed times y over 3 dy. Notice this integral 0 to 2 guy and 2 to 4, so these parts here, the integrands are the same. So it goes from 0 to 2, 2 to 4. You could actually write that as integral 0 to 4 then, put it over here. So it'd be integral 0 to 4, and that's going to be 3/2 plus 1 there, so it'll be 5/2. So it'll be y to the 5/2 over 3 dy. And we still have this guy distributing this, and it will be minus. I'm going to pull out the 1/3, that one. So it'll be integral 2 to 4. That will be y minus 2 cubed y dy. So instead of cubing y minus 2, I'm going to make a u substitution. I'm going to say let u equal y minus 2. So then du dy will equal 1. So then du equals dy. I'm going to make that substitution on this first integral here. So it'll be equal then. Just I'm going to pull the one, actually I'll integrate, I'm going to pull the 1/3 out there, but so integrating this guy, so it'll be y to the 5/2 plus 1 over 5/2 plus 1. That'll be from 0 to 4, and then a minus 1/3, making our u substitution, it'll be u of 2, then up here will be u of 4, it's going to be u cubed, so u cubed, y, but let's see, over here then, you can solve this for y, adding 2 to both sides, you'll have y equals u plus 2, so you could put u plus 2 here, and du equals dy, so you'd end up with this. Now u of 2, so here's my u over here, so putting 2 in place of y, this would be 0, and putting 4 in place of y here, this would be 2 up here. Okay, let's keep going. Okay, move it the other way. So 5/2 plus 1 would be 7/2. It's going to be, I'm going to pull 1/3 out of everything, so it'll be 1/3 in front. So it's going to be y to the 7/2 times reciprocals will be times 2 7s. Evaluated at 0 and 4. And that's pulled out, so it'll be minus then integral 0 to 2. So multiplying this in would be y to the 4th plus 2y cubed du. Okay, so let's keep going. Okay, so I rewrote it up here. Let's keep going then. So it's going to be then 1/3. So it'll be 2 7s. Putting 4 in place of y, it'll be 4 to the 7/2. Then minus integrating this, it'll be u to the 5th over 5. Integrating this, it'll be 2 u to the 4th over 4. This still has to be evaluated at 0 and 2. Okay, so 4 to the 7/2, that would be square root of 4, which is 2 to the 7, so that'll be 2 to the 7th. Okay, so this will equal then 1/3 2 7s times 2 to the 7th power minus, so putting 2 in place of u will be 2 to the 5th over 5 plus 2 times 2 to the 4th over 4. Okay, keep going here. So it'll be then 1/3. That'll be 2 to the 8th over 7, then minus 2 to the 5th over 5. Then this is 2 squared, so you can cross this off, and this will become a 2 up here. So this will just become 8 in here. So it'll be minus 8. So a common denominator for these would be 35 between 7 and 5. So changing everything to 35ths. So be 1/3 in front. So multiply to 2 to the 8th times 5 this guy multiplied by 7. And then the 8 multiplied by 35 all over 35. Okay, so equals n. So let you check, if you simplify this top up here, you get 776. You'll have 3 times 35, which is 105. So 776 over 105 is our answer. Okay, that completes part A of practice quiz 7, number 1. We'll do part B in the next video.